Welcome to homework.
Alrighty, so for this question, we are asked to compare the kinetic energy in two different situations. The first is if I have a sled at the top of a hill or a sled going down the hill. So let's draw, I just have my little hill right here. Let's draw a little sled, another little sled, draw this guy. It's a little arrow to tell that it's moving. So the first important thing to remember is that kinetic energy is the energy of motion, right? If something's not moving, it doesn't have kinetic energy. So because of that, we know that this guy up here is not moving, so its kinetic energy must be 0. Since this one is sliding down the hill, obviously it is moving, so the one sliding down the hill is going to have more kinetic energy. The second example is water going over a dam. So if I draw my little dam right here and draw some water just going over. All right, so we're asked, is there more kinetic energy right here where the water is just sitting at the top about to go over the dam, or right here when the water is already going over the dam? Now we can think about this one in a very similar way to what we did with this sled example over here, right? Since the water is falling here, it's probably moving faster than it is up here. So moving faster is an important thing because in this case, both the water here and here is moving. But we know velocity is very important in kinetic energy because I can write kinetic energy is equal to 1/2 mv squared. Since m is the same and since 1/2 is the same, what determines the kinetic energy is the velocity. Since the velocity is probably going to be greater right here, we can say that water